All right, thanks for coming, everyone. I don't know if we said that before, but we appreciate you all coming out, especially you guys from Ann Arbor. Taking a lot of time out of your day. So I'll be talking about some React and Redux performance optimizations you can do for your own applications. How many of you ship React Redux apps to production? Okay. Yep. So anyway, useful information nonetheless, even if you guys aren't using it in production, because some of this stuff can kind of creep up on you. You might not know it's a performance trap. So here, as of React 16, the add-on's performance measuring no longer works. And same with a couple of other performance libraries we've been using at Benzinga at least. Global Render Visualizer is pretty useful. It'll display like a border around all your React components and the number of times it's re-rendered and why it's re-rendered. And React Wastage Monitor is pretty cool. It'll log out like the reasons why your components have re-rendered to the console, so you can see, for example, this state changed, this prop changed, or perhaps the component re-rendered and it didn't need to. Pretty interesting stuff. It diffs not only the props but also the actual HTML output of your components, which is extremely useful because we don't want React to re-render HTML that already exists. But before we dive into like optimization, it's really important to stress that you shouldn't go all out on optimizing things that don't need to be optimized. For example, in our application, there are several components that just are pretty simple, pretty straightforward. They just kind of pass through some data into the DOM, and it'd be significantly more expensive to check those components and make sure that they shouldn't render, rather than just having them re-render every time. And that's measurable. I measured it and made sure you did that. And you can do that in React 16 by going to the user timings API, which you can get to from here in the performance. So if I do this, I'll explain this demo later, but I'm just showing the performance timing.
Never mind. I said that before I saw how much stuff you're trying to show.
So you can see here, like, this is what's going on in React. This is the measurements of each lifecycle method that React's doing, and this is built in, so you can just see this. You don't have to add anything to your app to see it. It's just there for you all the time. And you can get to this in Chrome DevTools by just going to Performance. I don't think it works in Firefox yet. I don't think they've added this user timings API, so that's kind of unfortunate. This just in Chrome, but it is what it is.
Any of that?
You can save all of this performance timings data. You can save the profile, which is pretty cool. Like you can record the JavaScript flame chart, which functions are getting hit the most, that sort of
When
thing.
you export it, what format is it in?
I think it's a format that you can then drag into this.
Yeah, it's just JSON file. But you can import it, or you can save. I'm pretty sure you can also save it and view it later. I'm not sure where it is.
So that file, I think you can drag that file in.
Yeah, you can from here. Yeah. Cool. So continuing on, there are some free Babel transforms that you can apply in production that will give you a non-trivial performance boost in our React app. So transform React constant elements and transform React inline elements. These are pretty useful. Constant elements, I don't know if you guys know this, but every time you write JSX, internally what the JSX transform is doing, it's calling React.createElements, and it's returning an object for React to interpret. So what this does, the constant elements, is it'll take those elements that are completely static and hoist them into a higher scope so that it's only referenced once and therefore can be reused more readily by React. Inline elements basically pre-compiles those create element calls. so that you're not calling create a whole bunch in production. So this is pretty useful because essentially what your JSX looks like is just objects describing what kind of React element it is, instead of a whole bunch of function calls. All right, so lifecycle. Let's just review this pretty quick. This is really useful, by the way. This React Armory site. It's got some pretty great simulators. I don't know if you guys have seen this before. They've got a few different ones, but you can see here. This is how the life cycle works for anyone who's unfamiliar. We've got our class initialization in the constructor. It's going to create a component for React to use, and then we've got component will mount, it'll render, called did mount, and so on. But where it becomes relevant for this talk is really should component update and then render, because should component update is your first line of defense against unnecessary render calls, and you can tell React, hey, this isn't going to lead to a change in the DOM. Let's just short circuit this life cycle and exit quickly, which will help you prevent unnecessary re-renders in your application, especially if you have a very expensive component. For example, like, I don't know, our entire dashboard in our app. Maybe you don't want that to re-render so much. So it's also important to note that if you return the same reference from render, that is, your output HTML is the same reference, and you haven't changed, you haven't created new objects in render, it'll reuse it, and React won't insert anything new into the DOM or alter anything in the DOM. So that's important to know.
That tool you have, is that just more for documentation, or can you actually like interact with it?
Which one?
This
one? You
yeah.
can interact with this, yeah. This is, I can't remember which one I have, but so you can, it's pretty neat. Very useful for learning the life cycle if you are unfamiliar. All right. So this code is direct from the React source. This is the default implementation of should component update and how the life cycle kind of works in that stage of the React reconciler. If you don't know what the React reconciler is, it's basically how React tells if something has changed or not in their virtual DOM implementation. So if should component update is defined, then it's going to call it and return that. Otherwise, it's going to check if it's a pure component, and what a pure component does is it just checks equality between the old props and the new props shallowly. So it checks if the references are the same. Otherwise, it will always update every single time. And this is very important because React has no way of knowing whether or not your application should re-render or not, right? So it's safer for React as a library to assume you should re-render something rather than not, right? Because it'll lead to an inconsistent experience for your users. Any questions on the reconciler? Anyone?
I am kind of wondering, if you have like a component high up holding another component
Sure.
in it, but that component is like, say, like your guys' dashboard, just basically a frame with icons, you can have that never re-render, but re-render everything within it, right?
So components have their own life cycles, right? So you can have a component in a child tree, like you're saying, that can re-render independently of the upper level component.
Right. Okay.
And the converse is true. You can have a higher level component update, but a child component won't if you implement should component update on it.
But like this will.
No, go ahead.
But like this will just prevent like both components from re-rendering and just.
No, this is per component, right?
Oh.
So this is just to let you know that the default implementation of should component update is true. So if you don't define it, or if you're using a stateless functional component that component will always update. That includes if the parent component updates or a component underneath it updates. So let's say you have a component that's a child component of another one. If neither of those have should component update, then if the child one re-renders, it could trigger a re-render of the parent one, right?
I was just going to mention, like, for us, this has been a source of some bugs in the past, actually, because
Yeah.
somebody implements, like, a very complicated component update on a, like, highly nested, like, small little component. And then before it was working because, you know, we had this, like, the parent rendering would cause the child to re-render, but,
Yeah.
like, later on in time, a new prop got added, and somebody forgot to add it to the should component update, and the damn thing won't re-render, and we're, like, chasing around trying to figure out why doesn't this re-render, and then, oh yeah, it's because...
Yeah, I've done that too.
Yeah.
Yeah. Generally consider best practice to try and avoid writing should component update where you can, because it does lead to bugs, right? You forget to add stuff, or you're depending on this behavior that it re-renders, but you're not aware of this implementation behavior, right? You're depending on the child components re-rendering when they really shouldn't, and then something changes, right? And you're like, what's going on? It's because of this. Okay. So one thing that's very important in render is when you're passing props to child components, is to always avoid creating new objects in props, because there's no way to compare them without deeply comparing them, and that is pretty expensive, right, from a performance standpoint. So you see this a lot, actually, where people will do arrow functions in JSX, or they'll do style. They'll do this. This is very bad from a performance standpoint. Inline styles in React are incredibly expensive to do. You should avoid them wherever possible.
You know, that's probably why our linter forbids it. I always wondered.
Yeah.
It's like super annoying.
It's extremely expensive, especially style. But more so, like stuff like an array, you can't deeply compare an array. For example, if you have like nested objects in there, it would take a very long time to compare, and it takes a very long time to render too, right? So you're kind of stuck between a rock and a hard place in optimizing that. Yeah.
Do you just move that code outside the JSX call and have it somewhere else or above in the render
So in the render method, if you're still creating a new instance, right, it'll still have the same effect,
Okay.
right? So, for example, like in the on-click here, you guys can't see the cursor. In the on-click here, what I like to do is create a class property or a method on the component, which will have access to all the props, and it'll do this. And because you're writing like this dot handle click, right? It's a static reference. It never changes in between renders. And therefore, that on-click prop won't be the reason why a re-render gets triggered.
Arrow function.
Yeah, the class property syntax for anyone who's unfamiliar is like it's like declaration equals arrow, and you have to enable a Babel transform to do that, because it's I think it's stage 3 now. Stage 3. It might be included in the Babel env preset by now, actually. Yeah.
So like what you just suggested with the on-click, would that be something you would do with style as well?
Yeah. So style, I would really recommend trying to avoid using style at all costs.
Well,
Right?
like so for example, like the app that I have to build, I end up using background images instead of
Sure.
instead of putting them in the style sheet, because the background image gets updated based on the API response.
Mm.
So for those elements, I'm using the style.
Right. So you can do it that way. There's nothing like technically wrong with that.
Yeah.
It's
Sometimes
just
you can define it outside of the class too.
yeah.
Okay. But like, I mean, would there be a better performance?
Yeah.
Yeah, so as long as the reference is constant, right?
Okay.
If you know ahead of time, for example, what the background image is going to be, then you can like require it, and then have a static reference
And so,
where
like,
you can
doing
make
it
the
outside of like the JSX.
yeah,
rendering, it's
yeah.
just gonna be-
So as long as it's not in like the render method,
Yep.
you know, or like for example, you could define it in the constructor, like
Okay.
this dot style equals whatever.
Yeah. Okay, that makes sense.
Okay. Any other? All right.
This applies to maps too. I do this
Yeah.
all the time.
Yeah.
Right?
This maps.
Instead of like for list items, you say you put like a map in there, for some kind of function that returns an array.
Yeah. Yeah.
Same shit.
So now it's
Functional
has to
programming
update it.
always returns a new array object.
Yep.
So that'll trigger the render.
Yeah, and it's pretty common too, like to have the braces
Yep.
in JSX, and you do like array.map, and you return a list of elements. It's pretty common to do that,
That's currently how it's set up.
but it may trigger re-renders if you're not careful. You have to make sure that array is keyed. Fortunately, React development will inform you need to put keys in there,
Yep.
but it will trigger a re-render. But React knows because the keys are the same, it doesn't have to re-render.
This is the benefit of using a library like Immutable is that you can create objects that can be shallow compared, right?
Yeah, yeah. So I'll get to that, but
Yes, I
because Redux is immutable, your state is immutable, that means you can shallow compare and kind of know. That's why it's very important to make sure your state is immutable. Anything you really care about in data passing to props and components should be immutable.
And if you have to do derived data, you might want to use reselect.
Yeah, yeah.
Probably get to that.
Yeah. So it's pretty cool. React Redux implement should component update for you. It shallowly compares the output of your map dispatch to props, map state to props, merge props if you're using that. It'll compare the props you're inserting into your base component with the old props and decide if you should re-render or not, which is why you can use something like Immutable and know immediately if you should re-render or not because the props haven't changed, right? They haven't changed reference. So with that said, it's also pretty important to avoid passing down state into your child components because they might not care about that state, or the top level component might not actually care about the state. It might just be passing it directly down. And when that state changes, that component and therefore all the components underneath it will all re-render.
You mean Redux state or React state?
Redux state. Redux state. It's pretty common to lift up the React state into parent components, but yeah. So when you connect lower down, because connect implement should component update for you, it means that you can make it so that your components that are lower in the component tree only update when the state has actually changed that they care about. They could have one thing re-render on one side of the screen that is completely unrelated to another, and you won't even have to implement should component update in your components, which does lead to bugs, right? Like it's a verifiable fact. So reselect and re-reselect, very, very cool libraries. They're used to retrieve or compute derived data from a state. And what I mean by this is, say you have an array of something, some IDs or something that you need from Redux. But you're not actually going to use those IDs. You're going to map over them and return something else, mutate that data in some form. Reselect allows you to memoize complex operations such that you don't have to redo them in your component lifecycle. It'll just, if the state hasn't changed, it's going to return the same result every time, which is pretty cool, pretty important. I like reselect because it has some cool optimizations for reusing these selectors. So say you have a selector that's dependent on something else, or you've got in our example in our app, we have like these workspaces, and each workspace has a number of widgets underneath of it. but we only have like the IDs of the widgets. We don't actually have the widgets themselves. So we can use the workspace selector and the widget selector and mash them together and just get the widgets we want. We don't have to like figure out what widgets we want or mess with the Redux tree at all. So you define your state access once and you don't have to worry about it. You can change the shape of the state without breaking your app. So I'll pull up this example here. So here's an example of how they memoize the results. Here, so let's say we've got a filtered list, and let's say we want active to-dos or just the completed to-dos. This is if you've got a lot of to-dos or whatever you have in your state tree, this could be a pretty expensive operation to do every single render, right? So what this allows us to do is only run this every time the state actually changes, making re-renders more performant. And the majority of optimization that you can do in React is reducing the amount of work that React does. You're not necessarily speeding up React, because React's fairly fast if you do things right? If you do things like return new objects in render, or do a lot of derived data calculations in render, it'll be pretty slow, pretty fast. Any questions on reselect?
So I've never tried using reselect. I know it's there, but I've just never tried using it. What's the main payout of doing this using the reselect library versus doing it in your reducer? Just like
in your reducer?
Like adding, so like in this case, like for give visible to do,
Sure.
adding a visible to do this property, or like sort of like you combine reducers and have like a visible to do property that does the same thing.
Sure. So you could do it that way, and you could keep track of all of the different states, right? That could get kind of complicated pretty fast, though.
Yeah,
right?
if it's like a big ugly reducer.
Because what happens
Yeah.
when you have that's one dimensional, because there's just like one level of nesting. But what happens when you have like red completed, blue completed, green completed? So now are you grouping by color and then completed, or no? Wait, are you grouping by completed and active and then color? And like, just speaking from we had an app that was like that, not too long ago, where there's a lot of work being done in the reducers and the actions. But this actually, it tightens it up a lot because, like Rob said, it allows you to have a really flat state tree, which is what you want, at the same time as being able to have these selectors that give you the views of the state that you really care about. So then you can change the implementation of the state tree, and the rest of the application doesn't have any knowledge of that. It's just using these selectors. And on top of that, they're memoized. So it's like...
Furthermore, like you were saying, if you have multiple interdependent filters, you can chain this selector with another selector that filters the result of this, right? So you get even more performance benefit. So say like your red filter has changed, but your completed hasn't. Only one of those selectors is going to recompute on the data. Yeah, it's pretty great. It's pretty great. And reselect is, as I said, a performance or an optimization on code reuse, because in reselect, in order to reuse these selectors across multiple components, you have to create a factory function that returns this because of the way it's memoized. In reselect, you can define a cache key specific to that selector. So say you want to cache on the ID prop that you give the selector, and that'll remain consistent across all your instances of that selector. And you can also reuse those cache selectors more easily than you can in reselect. In reselect, you can't reuse a memoized selector like a factory selector. You have to write two versions. You have to write this version, which is the non-memoized version, and you have to write another version, which is a factory version to use in your components. So that's that. All right. So this is a big one. I've seen this a lot where people don't normalize their Redux state. They just throw in lists of things because that's what the data looks like when it comes from the server, right? It might just be an array of items or whatever. But it turns out this is pretty challenging to deal with from a performance perspective. So say we have an example on the left. This is a denormalized Redux state tree, which means that, say I wanted to reorder these to-dos in some way. If I did that, it would cause a re-render of my entire list of to-dos because that entire array has changed reference because Redux is immutable. Right? So even though the to-dos inside this array may not have changed, just the order, it's going to cause all of those to-dos in that to-do list to re-render. So it's very important to normalize your Redux state to a logical extreme, let's say. Where that point is, you'll probably recognize when you get to it, but it can be very difficult to deal with highly normalized data, as I'll show in a little bit. So the normalized version of this, we've just got a list here of the order of the IDs, which means I can reorder how the to-dos will appear in the application without causing the to-dos themselves to re-render, if provided that each to-do component is only listening to itself in the Redux state, right? Which is where reselect comes in, and this is why it's important for this optimization. Any questions on the normalization? All right. So as I mentioned earlier, sometimes these optimizations are fairly straightforward, but they're not quite enough for what you're trying to do. So let's take a look at this. This is a kind of a recursive tree of items. So this is highly normalized in that I've got an item which has child items which are in the same level as the parent in this map of items. This is pretty good from a Redux perspective and from a performance perspective because you can listen only to a specific item. But this can be very challenging to deal with in React because you have to manipulate this tree structure in some way before you can actually render it, right? Because we're dealing with a single tree in the DOM. So there's a couple ways to deal with this actually, and in React 16 you can return an array. So in this instance, you could have an item component that just returns an array, or if it doesn't have any children items, just itself. So you can recursively return items, an array of items if you have sub-items. So let's go over this other method here. And this is using generators. Who here is familiar with what generators are in JavaScript? All right. So for those of you who don't know, generators are iterators, essentially. Do you guys know what iterators are? No? All right. So think of an iterator as a way to pause a for loop after every iteration. So I can do one thing, stop, and then restart the loop. And this is important because we're trying to lazily evaluate this tree, as you'll see in a second here. Actually, I'm just gonna do this.
It's a recursive strategy.
All right. Forgive me for my Windows VS Code skills here, please, because I use a Mac and I'm not too familiar with this. That's there we go. All right. So at its very essence, what this is going to do is it takes in a selector function, which is essentially just a function that takes in an ID and returns the actual object we're looking for, right? This could be a reselect function. It could be, something else entirely. So what this is going to do is it's going to go through all of the items you give it, all of the IDs you give it, and yield that item. And yield is essentially a pause button. So it's going to return that, and then it's going to stop and wait for you to ask it to continue. Okay? So this is a simplified version of what I'm doing, but it's functionally equivalent, as you'll see here. So let's take a look at this table. So this is lazily walking a tree of recursive table rows, and I can pull up what they look like. This is pretty normalized. So I've got some rows here, I've got columns, I've got a table, and I've got cells. So each of these have their own state tree, right? So they can re-render independently. They're all normalized, but how would you assemble this? You'd have to walk over this tree maybe 2 or 3 times before even getting to React, so that it can render to an actual DOM tree, actual DOM table. And this is actually pretty sophisticated in that it can handle rows that have sub-rows, and they're grouped by a column. So if you have rows that have like multiple rows and then rows underneath there, you have a tree structure that looks approximately like this. Here's a great example. So this is one row, and this is its first sub row, and this is its second sub row, and so on and so forth. It's recursive tree structure. So if we look at the table here, all we're doing is we're iterating over this lazy generator once instead of 2 or 3 times to figure out what's happening, and then we're just rendering out the results. So this is a pretty big performance optimization. Say you have a table with, I don't know, with 10,000 cells. That's fairly common for financial applications, at least, to have a large number of cells. At the last place I worked, it was very common to have these very large data sets and tables. So what this allows us to do is to really, really cut down on the amount of time it takes to render this, right? Because we don't have to iterate it 3 times and into the third, or whatever the ON notation is. And you'll see here, I have racked here, I can refresh this page, and only the cell 1 will actually re-render. Nothing else in the table re-render.
Where's sub 1?
Cell 1 up here?
Oh, new value.
Yeah, it changed the new
Oh, it
value.
changed. All right.
Yeah, so I can do that again, in case you guys didn't catch it. This is a very helpful feature, by the way, this highlight updates in the React developer tools. So yeah, I mean it's pretty powerful.
Could you point that feature out a little
This one?
clearer? No, showing the updated.
Oh, okay. Highlight updates in the React developer tool. It's a little checkbox.
Okay, I could barely see
Show
it.
down Pro.
Yeah, there we go.
Pull Pro up in a new window.
Is it local host running?
Yeah, no, because you're running your thing, but just go to production. Or beta.
So that's invoking the feature picture, but seeing it, I didn't really see anything to highlight.
So yeah, it's a little faint to see, but essentially what it does is it flashes a little border around what's updated.
Okay.
And this right now it's a little sparse because it's market hours are closed, so the quotes aren't coming in and updating constantly. But this stuff, like, it'll all update all the time when we get new quotes coming in. So you can see the stuff is re-rendering when I hover over it, for example.
I'm curious, during the day, peak of activity, that thing's just scrolling along like mad.
Christmas tree.
Yep, it updates quite a lot, especially at market open. We get like, I don't know, hundreds of stories come in right at 9 o'clock.
Isn't there a point at which it's unreadable? It's updating so fast.
So
That's
what?
the filtering's for. So you can filter. Yeah, like this
Okay.
point is like you get a fire hose and then powerful filtering on top of it, so you can just see the things that you're interested in.
And that's where some of the developer performance tools I demonstrated earlier or showed earlier, like the React Visualize Render, it'll actually show a render count next to each function, or next to each component rather in the tree, which is pretty nice. And it'll show you like what changed. So this prop changed, or the state changed, or something else, parent re-rendered, something like that. It'll show. Unfortunately, I can't show it here because we're on React 16, so it doesn't work. But
Just thinking about your application, it seems like you could average, say, a fire hose of data on a regular basis. A lot of other applications just simply aren't that.
yeah, for example, it's very
You've got unique problems, it sounds like.
sort of. But it is pretty common to have a performance issue if you have some level of complexity in your application, right? Even if it's just like, I clicked on this thing and it took a little while for the next UI to come up, right? It might not be that your application is constantly rendering, but you might like do a route change or something like that that leads to a new UI that you need to appear quickly. All right. Any questions on like the generator stuff? Yeah.
How often do you find yourself writing generators to like deselect Christmas Day? It's a cool idea.
So it was kind of like a, hey, I wonder if this will work kind of moment.
Can you show the Miller columns?
Yeah.
We only have one thing in our application that this is like perfect for, and it's this. By the way, I don't know. This thing is
Leave
called.
the widget unlocked.
Yeah, can you close the or like go to sectors maybe?
Yeah.
So like we have this this highly nested structure here, and this is a tree. This is a very straight up tree. But this was written before Rob was hired, and if it were written after he was hired, number one, he would have done it and not me. And number two, it probably would have used this approach. But this would be perfect for what he's describing, because this was like the amount of I've never written more recursion. There's so much recursion in this code for this component. I mean, it works well, but it's like hard to wrap your head around. And using the generator approach is actually like kind of I don't know. I think it would make it a lot easier.
Yeah,
because
this
you
is
can abstract things away.
It's really straightforward to read, right?
Yep.
Yeah, this is super straightforward to read. I mean, there's no recursion here. It's just iterating over
Well,
something.
there is the compiler.
If you look at the Miller columns filter selection in the app, you'll notice that when he clicks, go for it, everything re-renders, and not just like a checkbox, but anything in the list.
Yeah.
And that's partly because the approach is not necessarily friendly to, performance. It would probably be better written in the style that was presented in that table, for example.
Absolutely. Yeah, because each of these, in order to, so like this thing that Rob's showing here, where it shows like, can you do the Konami code?
No, I can't.
Okay.
I will do.
It shows that doesn't work anymore.
enable debug mode.
Well, anyway, I don't want to take over your talk, but the
Do it, you'll get infinite lives.
the each of those little items has to have a reference to its parent.
Yeah.
Because sometimes, like, so if you have all of the, like, if he clicks bankers and is that brokers and exchanges right now, I don't think that'll.
You just have to reopen it.
Okay, all right, fair enough. So if he clicks brokers, bankers and exchanges right now, is that all of them? Or can you select it? Oh, because these. Can you just get all of the? Yeah, click that to enable it. Okay, so you see here in the bottom it says Max 103. So the only thing that we're actually sending to the server is the one that's the parent of brokers and exchanges. So we displayed to the user that all of those are clicked and all of the sub ones of those are clicked, but it would be really computationally expensive for us, and we would blow up our servers if we searched like on that extensive list, because it's like the search is literally the same if we made if we just searched with the parent, because of the way the hierarchy works in the tree. So like the reason they all have to re-render is because exactly what Rob is saying, that in order to accomplish this, you have to walk the tree multiple times to get the UI that you're supposed to display, to be like to figure out all of the selection states, to figure out like the checkboxes, and to get those counts for the numbers. To do all that stuff, you can't do.
That's pretty expensive.
Yeah, it sucks.
Yeah.
You can't do it lazily with that approach. You have to just build in a reference to. And so then you get this recursive structure, and then you can get infinite loops that way pretty easily. It's like, I don't know if anyone's ever tried to like introspect at the immutable JI actual like objects that are stored there. It's the same thing going on. They have a lot of like recursive like things as their parents in the sub item lists. And it's for a similar reason. So yeah, it would be perfect. Maybe another. See, this is where we have problems, right? We're trying to make money, we're a business, and then it's not broken, so why should we fix it? But it would be cool.
It would probably be better.
I guess. Yeah.
So yeah, sometimes the problem is not necessarily that React is slow. It's that the way you've structured your data is difficult to handle in React. But there are ways to handle it. A lot of people would just choose to denormalize that tree structure and do what Dimitri did with the Miller columns and just do it recursively, because it's it's significantly easier to come up with in the first place, right? But that's where the power of the lazy iterators comes in, right? All right, cool.
Is that your car?
That's it. That's it. Thanks, guys.
That was great.
So that generator, is that something like you just wrote, or is that something?
It's a new feature.
Yeah, so it's a new.
I wonder when we're gonna have to stop saying it's new at some point. Right? It's been like 2 years.
2 years, we're at the point.
I don't know, but yeah, it's a thing. It exists in other languages. It's well used and loved in Python.
Okay.
And
This is the first time I'm hearing of that.
yeah, it's not surprising, because it's kind of like it fits into the like generators and promises and observables all fit into a sort of world together. They do, whether you're thinking about them pushing or pulling, they kind of like handle different domains. But yeah.
Have you heard of code